All right. Good morning, everyone. This session will be the continuation of what we did yesterday. We will touch base some of the concepts of what we talked about yesterday. And then the reason why I'm repeating this or talking about this one is the real model that it is applicable in the industry. OSI model is majorly for conversation, but this one really usable in the industry. It's usable in the sense that this is the format the vendors and all the standard like NIST documentation, like ISO, IOS, and then some DOS documentation. This is what it refers to. So we need to get ourselves familiar with it. We don't need to memorize anything. We just need to have an idea and then how the layer works. So if we look at the title, it is TCP IP suite. So it is not different from, it's not much different from OSI model, only that this one has 5 layers. It is 5 layers. So, or before it was 4 layers, but it has been updated. So, if you look at the left-hand side, we see the layers, the application layers, transport layers, network layer, and data link layer. It wasn't like this before. It was network access layer, network. Oh, no, the first one will be link layer. The first 2 will be link layer. The second one will be internet layer, and then they have in transport layer and they have application layer. But that has become obsolete. This is the updated version. So, and I love it because it's really go side by side with OSI model. So if you look at the layers, it is not much different from OSI model. The only difference is the TCP IP model condense the other 2 layers, the upper layers. That is the presentation layer and then session layer and application layer to 1. They condense them to be 1 because that layer is majorly dealing with data. It's majorly dealing with data. So, and then in that layer, we have some protocols that function on that particular layer. Like we said yesterday, we have some protocol like hypertext, transmission protocol. We have a DNS, that's the domain name service. We have SSH. We have all these protocols, they are more than what we can memorize. But important thing is we will touch base on some of the popular ones. So most commonly usable protocols. We touch base about that one, and then there's no way we can just know all these protocols because every day they evolve. We have some standard, we have some organizations shoulder with that. We have IEEE, which is International Electronic and Electrical Engineers. Those are they are one of the organizations shoulder to provide all this standard. And then we shouldn't forget the other time I mentioned that protocols. They are set of rules and standards. They are set of rules and standards to facilitate interoperability between devices. Because if everybody is doing their things the way they like, there will be chaos in the network. So that is this. And then another thing we need to remember when we are looking at application layer, we need to remember that all these protocols like HTTP, we have the one of S, we have DNS, we have SSH, we have SMTP. We have FTP. There are many like that. We have POP3. All these protocols, they don't function on their own. What this help us to do, what this facilitate is they facilitate communication between a client and a server. They facilitate communication between a client and a server. So they are not just function on their own, they are services. All these services, they have specific port numbers attached to them. And the port numbers, they are for identifications. Port numbers, they are majorly designed for identification because anytime the request is coming from a client, and then we shouldn't forget, when I mention client, is the PC. That is one of the jargons we use here in the industry. We call clients, endpoints, workstation, they are PC. You should just get used to that. So anytime a client have a request, to the server, this is a reply that should come from the server. So this particular server must have been configured to listen on a particular port among all these protocols before we can get a reply. For example, if you are talking about web browser, this client, or from this client, the user want to browse a page. They need, he or she goes to a particular website. There's what we call HTML .html file. Anytime we go to website, this is the file that will be open. So this guy make a request from this PC to the server. The server is being configured, it's been pre-configured. Everything we need is already on the server. It's not that the client will be the one designing that. It's already on the server. So this request understand certain protocols. That is the browser. That's why a lot of people, a lot of literatures talk that the browser is part of application layer. It's part of application layer because that is the layer the user click to go to the server. So now when this request go to the server, and then the server is written on one of these ports, and then anytime we go to browser, anything that has to do with web page is using this port, HTTP. HTTP. It could be S. When it is with S, it's the secure version. And then without S, it will be using port 80. With S, you'll be using port 443. With time, we get used to some of this port number. We don't need to memorize it. You don't need to know that they exist. And then as we progresses, we will know much about it. So if, for example, this server has no port configured, or no port is configured, or none of this port is configured to listen, or maybe it's configured to listen on port 80, the request will be, there won't be any reply coming from the server. So the functionality of HTTPS is to translate, it's to enable the server to listen on this particular port. There's another underlying protocol or underlying format that facilitates translation of IP address to domain name. Because end users, we are familiar with domain name like google.com, facebook.com. All those names, they have IP address, and then we're going to see them as we move on. They have their IP address. But the IP address, it is not convenient, or is not suitable for human being to memorize all the IP address in the world, or every time we want to go to a particular server, we need to know the IP address. So we are not too, it's not too comfortable. So that is where we have DNS. DNS, domain name system, to translate IP address into readable domain name. It doesn't do more than that. It can be vice versa. It can be from domain name to IP address, or IP address to domain name. That's all. It is as it is, it's broad. I mean, the DNS is broad. We have some underlying conversation, how it works, some of the structure of the DNS, the root server, the TLD server, what is support. We have 4As, MS, CNAME, and all that. There are many, but we won't go deep dive on that for now. But we just need to know that DNS, the major functionality is to translate the IP address to human readable format. If I have a server, this server, for example, it is mega.com. Let's say mega.com or abc.com. Let's say abc.com. How would these clients know that this computer is abc.com if we don't have a particular protocol configured on the PC? That's why all this configuration will be done in the PC before they can function as we expected. As we speak now, if we go to our system, we will see a position for DNS configuration. That is, a server has been configured to listen and to accept a request from the DNS particular name. So the device, they have been designed to intelligently know how to translate those names, because once we have a server for DNS already, there will be a server for it configured to know that, oh, abc.com will be listening, will be on this particular IP, right? So anybody coming to this IP or this name, you should translate the IP to this name. That is functionality of DNS server. It's a server on its own. I hope it's clear. So now this guy will type abc.com on his browser without worrying much about the underlying IP. The DNS would translate the IP to abc.com. It will translate the abc.com to the IP on the server side. So the translation will occur from the client to server. So anytime we want to start any conversation, whether on an interview or in the job environment, what should come to our mind is this conversation between a client and a server. Anytime, any day, it's always between a client and a server. Okay, now I'm in the office on my laptop and I need to open a share folder. I need a SharePoint. I need a SharePoint. SharePoint is like a inventory site where we keep some of the resources. So it is they call it now a kind of cloud-based application. It's a SaaS application. So now, anytime I want to get this file, this is my PC. There will be a server hosting this. In other words, it's still between my PC, this is a client, and a server. If this thing doesn't exist, I won't be able to access it. So all the conversation is always between a client and a server. Everything I've been saying since morning is all about application layer on TCP IP suite. We have other protocol like SSH, SMTP, FTP, POP. There are many, and I will give us some of the list where we can go and make research on our own. So because of time, let's move on to the next layer on TCP IP suite. It's not too different from what we did yesterday, but there are some variations that we just need to understand. And then we need to know that another model is existing that is majorly used in the industry. So if you look at it, all this one is just literature. TCP IP suite stands for Transmission Control Protocol, transmission control, and then internet. The IP is internet protocol. Look at it here. Internet protocol means the IP. Anytime we talk about IP address, it is internet protocol. It's a protocol on its own. We'll talk about it when we're doing subnetting. So the next layer we'll touch base quickly. I will not spend much time on the other layer because we've touched base on them yesterday. But let's quickly talk about transport layer. The transport layer is important to discuss much because there's a concept called three-way handshake that we're going to touch base now. And then I would love to demonstrate it in the lab to show us how it functions. What are the underlying protocols that facilitate the connectivity? So on the transport layer, like OSI module layer, we have segmentation. And then the two major protocols that functions on this layer they are TCP and UDP. Yesterday, we said TCP, it's Transport Control Protocol, and then UDP is User Datagram Protocol. We said UDP, it is connection or connected oriented or connection oriented. It is based on the author or the people that develop it, they embedded some capacity to make sure that if there is an error or there's a breaking down of there's a loss of packet, the protocol should be able to retransmit the packet. That is, it has error correction capacity. Error correction capacity. So that is TCP. And then, like I said just now, the conversation between when we're talking about TCP is not about isolation, because most of the time, even before now, I watch a lot of videos, this and that. They don't mention that the conversation is between a client and a server. That's why we cannot learn all these concepts on isolation. We need to learn it and attach it to something, their functionalities. That's the way it can be ingrained in our minds. So when we're talking about TCP or UDP, we are talking about client and server. And then let me talk about TCP quickly. In TCP, because we said it is a connection-oriented protocol, so what it means is anytime there's a request from the client to the server, the TCP will initiate what they call three-way handshake. There will be an initiation from the client to the server, a three-way handshake. So the handshake will be like this. It will be 1, 2, and then 3. Let me make the arrow face where it's coming from. So this three-way handshake, it is easy to understand, but most of the time when we are in an interview, we should endure to paint more picture or elaborate more on it, because I will not say the other parts, because there are some other layers after the three-way handshake. I won't say that one today. So, or when we go to the lab, we may look at it. What are the other underlying protocols that three-way handshake uses? So three-way handshake, if somebody asks what is three-way handshake, we can't just say three-way handshake is syn, arc. No. We should be able to explain that it is conversation between a client and a server before any connection occurs. The client will send a sequence number that contains syn, arc. So the request comes from the client, and then the server, if the server is authorized to listen to this client, there are some other things that can make this not to happen, but we are looking at it from ideal situation. That is, the client sends some sequence number, that is SQ, to this server, maybe 1. And then yesterday we talked about session. So when this request come from the client, say go to the server will reply with syn arc. if everything be equal on the client too, there will be another request or the final validation from the client to server to be ACK. All this ACK is acknowledgement. ACK and acknowledgement. Before any connection can occur, this connection, it is not a message because sequence is a message, but the connection part is not a message, it's to send data. So in other words, if before any sending of data between a client and a server occur, there should be an establishment. It is an hello message. Hello. That's why sometimes I just see that some of this technology, it is not far from us. It is like when we meet a new person and then we say hi, the person say hi, or hello, the person say hi before the conversation occur. Sometimes when we say hi to somebody, there's no response, there's no point continue conversation. So the conversation that occurs between these computers through TCP is called three-way handshake. This three-way handshake, it's not happening in UDP side. UDP doesn't have that capacity. It doesn't care about whether the client is listening, whether the server is receiving it. Its own is just to keep sending the messages. And then every ACK, if we can, every sequence messages, if we can deep dive on that, maybe during interview, we can explain more that there is a sequence number attached to it because different clients may be sending requests to this server. So each of this session will be labeled with a sequence number. Okay, if this client send a request now to the server, for example, it is labeled O sequence 1. Another client sent to this server a SYN ACK. It may be labeled sequence 2. Like that, because we have thousands of clients on the internet requesting from this server. So they will be having a message or PDU that will have sequence number. Just to identify particular computer that the server is replying to. Some other stuff we have attached to this, but we don't need those one for now. We have a window size, we have window scale, and some other stuff. But if we can just remember that there's a sequence number, and then the three-way handshake occurs between a client and a server before the data or the connection is established. That is that. We have some other protocols. Like yesterday, I said we have a quick. This quick is not too common now. So we won't talk much about it. Even nobody has been asking about it, but we just need to know that there's another protocol that is in the industry now. Well, anytime it is embedded in Chrome browser. So anytime we are using Chrome browser, this is probably that we are using this quick protocol, not the TCP or UDP. So any questions so far relating to UDP or TCP?
What is PDU?
PDU is a protocol data unit. It is a message that is sent by all the layers. It's a message. That's why when I said the PDU that is sent, that's instead of using message, because this is what the industry do. They use some names, some terminology to cover something simple. This PDU is a message, and it's always attached to different layers. And then yesterday, we shouldn't forget that we mentioned encapsulation and de-encapsulation. So anytime the encapsulation is occurring, we have, okay, let me use this diagram to depict that. We have 1, 2, 3. Okay, I'll start from up. Let me start from bottom up. Okay, this is from the application, we have data. When it goes to transport layer, this transport layer have a TCP or UDP. For example, if this data, I will be using D, it is browser based. For example, there will be another attachment from the transport layer, because application layer is dealing with only data. I hope you remember that. So when it comes to transport layer, there will be an attachment of TCP. TCP will attach to it. There will be data here. Only 2 PDU we have. Once it comes to network, which I've not explained deep on this one now, there will be an IP. And then yesterday we mentioned that on the network layer from the OSI model, we have a router. The router will facilitate or make a decision where to send a particular packet to, how to make that decision, how to send the packet. Quickly, router sounds like the way we send our email, our mail. This is my house. My own is just to put my mail in my mailbox. And then it's the job of the PO box or post office to send my mail to any place I want it, whether local or international. So my own decision is just to make sure that my mail is delivered. I don't care whether if through air, through moon, through sea. What I care for is I want to track my message to see that there's a progress and it's delivered. So the post office will make that decision either to use truck, to use air, to use moon, anywhere. They can even use drone to deliver the message, either locally or internationally. So that is functionality of the router. It serves like a POS. So before it can function like it serves as a PO box. Before that functionality can occur, there's what we call routing table. We talk routing table. This routing table, most of the connected devices, they will be sending their information to this. Say, oh, if you are going to Georgia, this is where you follow. If you are going to certain places, this is where you follow. So that decision will now facilitate the router to send the packet to expected destination. There are some other attached protocols that will make that easy. Like now, yes, the other time we were talking about MAC address. MAC address, media access control, MAC address. It is for identification. That is where this guy come from. Like when we are in our environment, we have zip code. Every environment have a zip code. This zip code, it is unique to every location. The same way IP address will be unique to every devices on the network. The street name is unique. Okay, we have street name, the same street name in New York and the same street name in Georgia. What will now be a tiebreaker? The tiebreaker will not be the IP address. So now, what is possible to change between a street name and zip code? I believe zip code it is a permanent stuff. And the street code is permanent. And then I just want to represent IP address and MAC address with this analogy. But what we need to have remember is MAC address is permanent, IP address changes. But when we send a packet, all these devices, they are intelligent to know where they come from. There's a protocol I will discuss as we move forward that will facilitate, that will tell the switch where the particular packet is coming from. I will touch base on that. So quickly, so before the layer, after the layer, network layer, let me do this before I forget. There will be another attached protocol, that is IP. IP will be attached. TCP will be attached. All these attachments are called headers. They are called headers. They are called footers or trailers. On the last layer, both the data link and physical link, they will attach other layers like the MAC address, IP, TCP, and data. Yesterday, somebody asked a question. What is different between encapsulation and de-encapsulation? If you look at it now, from the top to bottom, what we are seeing is encapsulation. On the other side of the server, the machine will de-encapsulate all this from the layer 1 to layer 7. In other words, once the packet is sent to the server side, the MAC address, because this IP address coming, it has source and destination IP. We'll talk about that one later. So the server will remove all the unnecessary trailers as you move up on the layer stack until the data is delivered to the machine or to the user. So the functionality of network layer in TCP/IP is to make forwarding decision by router. It is not different from what we talked about yesterday, but I just re-emphasize on it. So data link and physical link is not different from OSR model. Data link, we have frame. And then from the physical link, we have bits. And then there are some protocol that function here. Yesterday we talked about interface. We talk about transmission of from bits to from the data to electric signals that can traverse the wire, which is 0 or 1. When we are doing subnetting, I will emphasize much of this. Okay, another thing I want to quickly paint picture to is this TCP three-way handshake. So let's go to my lab and then we look at how it behaves. There's a utility called Wireshark. Wireshark is for analysis. It is for forensic analysis. It is a whole job on its own, but we can just use it to troubleshoot. We use it majorly to troubleshoot and then analyze the packet. So let's go to my lab. This is my lab. If you can see it, this lab is called EVNG. Anybody later or our web set it up if our computer can carry it. But this one I host it on my server. I have a server where I host it. So the important thing where we are here is to demonstrate three-way handshake. So this is my window browser and the window user. I will click on it. So the window page will open. This is like window in front of us. The difference is this is a virtual machine. So before I do anything, let me open the Wireshark. I will right click on this switch. I will click on capture. So which interface I want to capture from? Let me capture from G0/1. That is everything that window user is sending. I want to capture it. How this won't happen, the people that design this EVNG, they've embedded Wireshark into their environment. So it's not that we're going to install it on our own. It is by default. If you look at the conversation, even before I run anything, the conversation is going on between this window and the switch. If you look at here, we are seeing that we have a switch ID. We have STP. There are some conversation going on between them. And then this is what I've been talking about this morning. This is the layer from the Wireshark. So let's not do multiple things together. Let me go to the browser from my machine. Okay, this is my machine. So what I want to do, I want to go to the browser. So I will click on Google Chrome from the window. It's like clicking in from your own laptop. So this is a virtual machine, but it's still the same. When we talk about visualization, I will discuss about that. So let me try to go to facebook.com. As I click enter, this side, though I've no, okay, this one I can't log in. So let me go to cnl.com, cnl.com, because I don't have an account for Facebook. All right. Okay, let me filter if you have TCP on this now. All right, can we all see my screen? Hello?
Yes.
Yes.
Okay. So now, when from my browser in my lab, when I try to visit what's it called it?
CNN.com.
CNN.com, we can see that we have some information displaying here. And then when I filter with TCP, because this is the protocol we are interested on, and then we see the message here. This is the SYN. And then look at the sequence number. It has 0. This is the window size. So now, if you look further, we see that the first thing that come here, the first request is SYN ARC. This is here. I don't know, maybe also all of us can say it. This is SYN ARC. This is the first message is the SYN from the top. We'll be seeing, okay, let me cancel it. This is the first one. 443, SYN ARC, and ARC. It is very tiny and I cannot even expand it. But the demonstration is just to show that before this conversation can occur, we see that we have SYN from the top with sequence number, and then we have SYN acknowledgement. If you look at the acknowledgement, it has equal to 1. And then if we look at the ARC from the client, we have sequence equal to 1, acknowledgement equal to 1. Those are the identification number. So if we go to interview, we should be able to explain a little bit deeper to show that we really understand what we are talking about. If I search with another protocol like DNS, and I click enter, we see that we have a DNS protocol underlined. This is the DNS, this is the protocol that facilitates from my request. This is my IP address of my PC, 192.168.10.15. And then the destination is this. Look at 8.8. This 8.8 is the DNS server that's sending this query. And they translate the IP address of the particular browser I'm going to what? It translates the name to the IP address. Because if, for example, now, if you want to deep dive a little bit, if I copy this, CNN.com, and I go to my PC, and I type NS lookup, and I paste the google.com, and I paste CNN.com, but I've not pasted anything yet. Let me just paste CNN.com. Once I enter it, it shows that CNN.com has varieties of IP address. It has IPv6 and IPv4. So now, if you check one of these IP from our Wireshark, let's try to check one of these IP from the Wireshark. Let's check 151.101.195.5. Let's try to check if you have, okay, it doesn't, doesn't give us something like that. Say feature IP. Let me see. Okay, there will be an underlying stuff as IP address. So I want to filter IP address. So I will now use 151.101.195.5. So let's filter it if eventually we have anything like this. Okay, we can see that it's one of these IPs that the DNS translates our request to. And then these are some of the stuff I was talking about before. If you look at it, we see TCP retransmission. That facility is to correct error. It is error correction capability. Maybe when I make the request, it didn't go initially, and then it retransmit it. So that is that. And then if you look at up again, we see SYN ARC, and ARC before the communication can occur. So that is that. Another thing we can quickly take a look at, or another protocol I want to discuss. Okay, before I jump away from here, any question relating to this? Is it cleared? Some of these things we need to try it on our own, demonstrate it, and then when we're okay, let me quickly come here before even if there's any question. You know, when we're talking about layers, this is the layers in the wire. Look at the frame. The frame is talking about layer 2. And then see encapsulation type, the Ethernet. Look at the dates. So all these formats, it is in the wire format. It is not something that's visible to us. But when we are talking about OSI model or TCP/IP model, they are referring to something like this. This utility, which is Wireshark, they've done a wonderful job to let us see it in real time. Look at the transmission control protocol we are talking about. So if you look at here, we see that it has source ports, and then we have destination port, which is port 443. This thing is intelligent to know that we are going to the browser. And then look at the sequence number. Look at the sequence run number. This is acknowledgement number. Look at the header. This is the window size. All this, the only time we can be asked this kind of question is when we go to like vendor specific interview. Like maybe we want to work with Palo Alto, or we want to work with Checkpoint. So they want somebody who can analyze this kind of data. So that is that. So let's move on to, let's go back to our notes. So basically we have touched base in all these layers from layer 5 from top to bottom. That's application layer, transport layer, network, data link, and physical. It's not too different from OSI model, but I just want to emphasize that this model is the one that's really usable in the industry. That OSI model is majorly for reference. So IP address stands for Internet Protocol, ICMP. ICMP, we touched base about that one maybe when we are doing some troubleshooting. It's for troubleshooting purposes. Internet control message protocol. We use it to troubleshoot if certain communication is not existing. This is the real time. Every time, this is the most usable protocol. We use ping. Ping is part of SMP, and it's to check availability. So this SMP, most of the time, it is allowed in the firewall. That is, we have SMP request and SMP reply. That is that about SMP. And then we have another protocol, ARP, which stands for Address Resolution Protocol. This one, its job is in layer 2. And if you look at it, I say its job is to find the hardware address. This is the job, this is the ARP that works between the client and the PC, and between the client and the switch. Router does the same thing, but that one is from the, maybe we have layer 3 switch. Layer 3 switch. So the ARP is the protocol that we let this switch or the layer 3 switch, or the layer 2 switch to know the specific client that make that request. Because of what? Because of the hardware address. I mentioned that this MAC address is engraved or soldered to the motherboard. So anytime this guy send a packet or a request, this switch is intelligent to know that the request come directly from this guy. So that is functionality of ARP, and then we have different ARP requests. We have reverse ARP, proxy, gratuitous ARP, and these and others are just literature. But we just need to know what's the real functionality of ARP and all that. So I've touched base on DNS, what it does, HTTP and HTTPS. HTTP and HTTPS is majorly listening on port 80 and port 443. For some of us who are still new to the industry, we should know that port 80 is not secure. Port 443 is the secured version of HTTP. That's why it carries S. The S there is secure.
What is the difference between port 80 and port 8080?
There's no difference. It's just for customization. So that the attackers or malicious users or the nefarious people on the internet, they won't just know what our server is listening on. Is to create a little layer of security. So if we see server configure like port 8080, this one will be set in the server from the get-go that you should listen on this. This is allow for customization. You can see this one to port 4443 in the production, just to disguise the attackers, because attackers will be looking for server listening on this default port. Just to make it not to be default, we now make it like this, but you see the same underneath. Is that okay, or does it have answer your question?
Yes, yes.
Okay. So we have SMTP. SMTP is system monitoring. No, this is That one is a SMP. This is a system management transmission protocol. System management or monitoring transmission protocol. So it's majorly used by the server, that is syslog. Syslog, they always use this protocol to manage system. We have another protocol called okay. We have another protocol called NTP. That one is common in the network in production. NTP. These two, they are majorly for monitoring or management of devices. Or the other one I just put now, NTP, is for network time protocol. This is to make sure that all our devices in the environment, they have synchronized timing. Not that one is having EST, one is using IST, one is using CST. So we should use this to synchronize our devices to listening or to have a uniform timing. All this, we can still read more about this on our own. DHCP, UDP, I've talked about UDP and FTP. FTP is not secure version of FTPS. FTPS is a secure version. This is for file transfer. This just measure is to transfer file. Most of the server, they listen on that. Anytime we are transferring file from WinSCP, this is the protocol we are using. We are using FTP, and then we'll talk about UDP. DHCP, I will just talk about it small now. DHCP is Dynamic Host Configuration Protocol. This protocol is, on one word, to understand this one, for somebody who is learning for the first time, it is automatic way of assigning IP address. Auto or dynamic. Dynamic is most commonly used in the industry, or static when we are assigning IP address. This is just a way of assigning IP address. As you are listening to me now, your router in your home, that's your service provider router, it has capability of DHCP. Every time we allow a device to connect to our Wi-Fi, they get an IP address. That IP address is assigned or leased from a DHCP server. That is the functionality of DHCP. So that is that. Any question again related to what we have said so far? So in summary, TCP IP model, it is a reference framework like OSPF, like OSI model. So most of the time they compare them side by side, but like I said before, OSI is majorly reference in conversation, and there is the one we are using, because when we are talking about layer 7, we're talking about nobody talk about layer 6 or layer 5, layer 7, layer 4, and all that. So we only make reference to that. But TCP is the industry welcome model that the vendors or the PC or the industry manufacturers, they use whenever they want to create a system or they want to follow a standard that will make sure that their system is fitting into an environment. Now, if Nigeria want to start now, or any other country want to start producing phones, they will need to follow some standard. This TCP/IP will be the reference standard to work with, because it highlights all the models and all the RFC that need to follow to make their own system, their new system to be interoperable with other systems in the industry. So this is 9:12. This is where we're going to call it a day today. So if you have questions, let me know, and then we'll take a look at it. And we try to list some of the other protocols that we can get acquainted with. So next time, by God's grace, we're going to meet, we're going to deep dive on subnetting. So from subnetting, we look at how the protocol, how the IP address is being created, what are the types, how we can generate it, how we can assign IP address to devices from our subnet. That subnet is one of the most simplest theory or topic, but it's one of the most difficult one. Why I say that is, if anytime I explain it, it will be very clear to everybody. But once we don't visit to practice on our own, we go to forget it immediately. Because it requires a little bit of practice, because it's like hands-on on its own. We need to practice it. Because it's very confusing, but it's simple once we understand it. So, and then it is usable both on-prem and in the cloud. Because in the cloud, we'll be given like /16 from the from the cloud provider. So it is now left to us to divide it or to assign the IP the way we like within this subnet. So with that, having the knowledge will help us to make informed decision. Because some people, when they see /16 for the first time, you say, what is this? So we can deep dive on it, and then we get the idea. So like I said yesterday, most of the time for interview, they ask about three-way handshake questions. They always ask about it. Even if they don't ask about it, in the process of us explaining, we should mention, when we are talking about, tell me about difference between TCP and UDP. It is not enough to say one is connection oriented and the one is not connection oriented. No, we should be able to explain deeper, to explain that TCP has error correction capability. It can do a transmission of packet, and then it has three-way handshake. So that is where we're going to call it a day today. So if there's no question, okay, somebody send a question to the chat. Okay. Oh, are we ever going to do labs? The answer is yes, we're going to do lab. So, okay, maybe by next week, let's set up the lab next week, then we'll do visualization next week. I wanted to do subnetting first, but we can do visualization next week, and then we set up the lab. So once we set up the lab, we can start playing around that. And then in the beginning, we tell ourselves that the laptop that is required for lab, or the PC recommended for the lab, the configuration, the capacity, we've said that. So not everybody will be able to do the lab based on the device, based on laptop size. But there's a packet tracer that is very simple to integrate. There is a very light client, very lightweight client. So packet tracer is there, but it has some limitations. But it's good, it's better than nothing. That's what Cisco, they only recommend for their training environment. But this is what I'm using. I'm using EVNG. EVNG is they call it next generation platform, but since when I've been using it, I love it, and then I've been enjoying it. So this is what I'm using. There are so many lab. We have Genestry, we have Evengy, we have Peanut, we have them a lot. But everybody should decide what works best for him. Like me now, this is what I'm using, and I'm using the paid version. This is not free. So this Evengy has free version and paid version, but this is a paid version. I only buy license for it. If I go to, let me close it here. If I close the tab, this is my license information. So and it should soon expire self. This license will soon expire. So let me see the license information. Okay. 2025 04/19. That is April 19. So that's it. All right. Thank you, everyone. And then there should be bye-bye for now.
Thank you very much, Mr. Abi.
Thank you.
Thank you so much.
Thank you.
Thank you, sir. So
Thank you,
bye-bye.
sir.
Thank you, Ab.
Oh, boss.
I did
Thank you, my brother. How are you?
Hey, leader, I greet you.
Yeah, thank you so much. You make
You
it so,
don't have any question?
you simplified it very well. You really simplify it, and once I keep studying, and if there's any question, I'll be touching base with you.
Okay, that's good.
Yeah.
Because most of the time in the interviews, they don't want, they will never ask big questions. They want to ask simple, basic questions. All this I'm explaining is basic. So they want to test the person. Even we, for example, now, if you want to employ somebody, maybe we have workshop, for example, and they want to ask a question, or we have a
He doesn't know how
to sell a car. We
because
cannot ask the person big question.
This
It should be very simple question to start with.
No, yesterday when
So the same way in this industry, they always start with simple question. Okay, somebody who doesn't know about TCP/IP, will he able to know how to configure the firewall, how to configure router? If he or she doesn't know TCP, they say, what is TCP? He started mumbling. He or she started mumbling. So, but if the person can say, oh, TCP is this is what it does, they will know that this guy has an idea. Nobody's perfect. Nobody's super intelligent, but at least they only want somebody who have an idea.
Yeah. All right. Thank you so much. So once we get the material, we study and bring up some more questions, and we will be looking for the recording for today, right?
Yep. I will send it across.
All right. Thank you so much.
Notes, I will send it to so that we can take a look at it.
All right. Thank you so much.
Thank you, Stu.
Thank you.
Thanks.
All right.
Thank you, sir.
Thank you.
Thank you, everyone. Bye-bye.
Bye.
You want to know what?
Nothing.
Hold on.